My name's Carbin, and I looked at the heavy metal concentrations of Mytilus adulis of two different age groups found within the Foul estuary. Now, I felt it was necessary to analyse the impact of heavy metal which can enter the Foul with myriad of means such as leaching, surface runoff, carbon emissions, and oil or chemical spills, just to name a few. I did this by using light spectroscopy to look at zinc and copper concentrations in adulis. This was, to judge the impact of heavy metal concentrations in the Foul. Now, my hypothesis was to see whether there was a correlation between age and the amount of heavy metals found within them. So, a bit about mussels. They are sessile organisms. They live in big clusters all around the Foul and just everywhere around the coast of Britain, massively common. Because they're so common and because they're so good at concentrating a toxin within them, they've been used extensively as bioindicators. For example, with the mussel watch scheme around the US coast, that's become massive over the past few decades. So that's why they were such an ideal species to use. So other interesting things about mussels, they're bivalves. That means two shells, but technically they only have one shell, held together by a sort of hinge. And they attach to rocky sediment using their byssal threads, which are 5 times stronger than a human tendon. Well, with force. So the elements I looked at were copper and zinc. So copper can enter through loads of ways, as I mentioned, mainly fungicides, and also following the ban of TBTs, they've been used as anti-fouling paints. Adulis have very high tolerance for copper. In fact, it's been discovered that they can concentrate 60 micrograms per gram of dry weight, which was once considered lethal. Zinc as well is very abundant and very potent in high quantities. Both of these are essential for organic life, but can be hugely harmful in big amounts, such as causing stunted growth in mussels, larval abnormalities, and shell deformities. So I took 20 mussels from the shore between the Greenbank Hotel and the Falmouth Yacht Club. That's it under a high tide, and there it is with low tide. So I took it from the man-made crevices in the walls that are quite sheltered from predators. And there's some pictures of the area where I took it from. So lots of anthropomorphic features such as pipes, lots of invertebrate life as well on the wall, such as the breadcrumb sponge, limpets, and barnacles. This is quite a good indication that it might not be too polluting, because invertebrates such as the breadcrumb sponge are quite sensitive to heavy metals. So I looked at the growth rates in order to judge their age. This was quite challenging. I looked under a microscope and sort of didn't use mussels which were too worn or abrased on their shells, so properly look at the rings. That's a technique which has been used massively. Looking at, I did older than 5 years and younger than 5 years, because that was sort of mean which I'd got from looking at several. I took out the tissue from within the shell and dissolved it in nitric acid. This was in order to undergo light spectroscopy, which requires a liquid, so that just gave me a result for zinc and copper straight off the screen. And I used the t-test for statistical analysis. My zinc results, that was from the zircon method for light spectroscopy, and the copper results were from the paraffin method. After using the unpaired t-test, I discovered that with a p-value of 0.5221, it was not statistically significant under conventional criteria. Therefore, I accepted the null hypothesis. So that might say to us that mussels does not have an apparent impact on zinc and copper. However, so we could infer that heavy metals is not a primary concern, but maybe with a bit more evaluation and a bit more studies that it's not completely apparent. So there's a lot I could evaluate on. This slide barely scratches the surface. I mean, I could look at different locations further up, further out to sea and further up into the fell where there are more sources of pollution. I can analyse more water samples, different bioindicators such as the breadcrumb sponge, and using flame spectroscopy, which would look at the solid tissue, so I could look at the shells as well. Also, shell length is another thing, as I mentioned, stunted growth from heavy metals. Yes, I had some great source material. Gibbs and Bryan from Plymouth, they did some great studies on the biohistory and their heavy metals, and Elizabeth Gosling